Good morning and a very warm welcome to all of you for today's session. Actually, today's session is focused on the theme seismic design of steel structures. And we have with us an eminent industry leader, eminent person, and expert with us, engineer Dr. Abhay Gupta, one of the directors of Skeleton Consultants Private Limited, Noida. But before going to the session, I would like to take a minute so that all the participants can join and can attend the session. And meanwhile, also, I think you must be waiting, or you must be having in your mind that what you are expecting from today's session, right? So in that way, I will also ask you one question that what you are expecting from today's session. You are expecting something to understand the key principles of seismic design of steel structures or how they are applied in real projects, or you want to learn about latest code requirements, best practices, and common mistakes to avoid in seismic steel design, or you are expecting to see some practical case studies that show how failures can be prevented through proper detailing and analysis, or maybe you are looking forward to gaining insights from experts on modern tools, design approaches, and innovations in seismic resistant steel structures. So if you can see it in the post section. You can reply and you can just tell us what you are expecting from today's session. And I'll just wait for your question. Yeah. And yes. And also, I'd request you to put your questions in the chat section. And at the end of the session, we will be taking care all the questions. And because we have an expert with us, he will be taking care of all the questions and answers. And I think we can meet your expectation, fulfill your expectation, what you are expecting from today's session. But before that, I will be a little bit talking about in a brief why we are here today, what is our today's objective, and what is the purpose of organizing this webinar. Because the topic seismic design is very relevant for industry, for today's industry, because there is new Indian standard already there, IS 1890 Part 1 and Part 5, which has released just last year in November. And we all know that there are massive changes. It's kind of reinvented, and also there are some changes which the industry is thinking how to implement, right? And even if we see the earthquakes, what is there in past days, even last 2 weeks ago, also there was an earthquake which happened in Myanmar. The epicenter was in Myanmar. The magnitude of the earthquake was quite high. It is 5.9, and the tremor was felt in eastern part of India, in Bangladesh, in Myanmar, everywhere. Even in January, also this year, we have experienced one earthquake of 4.9 to 5.2 in Assam, Dibrugarh region. Little bit going back like 1 year before, there also we see in January in Delhi itself, the earthquake was there of magnitude of 4. So the thing is that earthquake is happening everywhere, right? I mean, every now and then somewhere, some part of the world. So it's unavoidable. What we can do, we can make our structure resilient, we can make our structure safe, we can reduce the vulnerability and all those things. So basically, what we are targeting, we want an earthquake safe and earthquake resilient infrastructure in India. And in that way, Seismic Academy is also in the same alignment. It is also with the same topic what we are talking about today. Seismic Academy is a knowledge sharing platform. It's an information based platform. It is basically basically with the alignment of what is going on there in earthquake. It's an initiative by Healthy India. It started 4 years ago, and we are also thankful that we have an advisory board member of all the person who are key stakeholders, who are leaders in this domain. Even outside of domain, we get their continuous support, we get their continuous involvement, guidance to run through this journey. And also we conduct a lot of activities throughout the year. One is, of course, the webinar, the quarterly webinar for which we are here today. So this is the first webinar for this year, and we conduct webinar around seismic topics. It can be related to health sector, it can be related to steel structure, concrete structure, even the spatial technologies which are there, like some passive control system, base isolation, damping, all those things also we cover through webinar. We invite academicians, we invite industry leaders also to spread the information, to spread the knowledge across the industry for the practitioners and professionals and also students. Also, we bring out trimester journals. Uh, and also through journals, we publish a lot of technical papers, articles, and also real-time case studies from industry. And last year, we started one activity which is for the students, like student competition. They can share their research work through papers with us, and we have advisory board members here from industry, from academia, and they will judge, and the student will get the chance to present during our annual conference. They can present the paper and it will be published, and also he or she will be rewarded. So in that way, we always try to motivate students also to continuously engage in this seismic awareness activities which is going on in India, and it is a booming topic. It is a very, very developing and popular topic. So apart from that, we are also involved with external associations, government bodies like BIS, NIDM, BNTPC, and also ISI, ICI, ISTRATI. All those associations are also with us. We conduct workshops, we conduct webinars through them also, because we want to be aligned to whatever is going on in industry. And as I already told that we organize annual conference every year in September or October, and it happens in Delhi, India Habitat Center. This year also on 16th October we will be having the annual conference for the full day, and every year we focus on different theme. Like 2023, the theme was healthcare sector. 2024, the theme was for codal shift. 2025, it was focused on building retrofits, because we believe that the retrofitting and strengthening will also be a very, very important topic for everyone, because IS 13935, which is relevant for seismic safety assessment and retrofitting of structures. So this is upcoming, and this will be released by BIS very soon. So we also try to make the theme in that way, and we invite national and international speakers over there. Last year also we got overwhelming support, and and I mean, all of you are very, very welcome over there to be a participant there. And if you're a student, you can present your paper, and also you can just enjoy the session. And also, apart from that, we are involved also promoting a lot of e-learning courses. If you see Seismic Academy website, then you can see that there are e-learning courses or modules are available around seismic design. The one which you can see first is by Professor Yogendra Singh on earthquake safety in engineering. So all those activities, apart from journals, publication, and conferences, we do because we believe that educate to elevate. Because we believe if we educate ourselves, we can elevate ourselves. And yes, that is the primary intention of today's webinar and also Seismic Academy initiatives. And with this, I would like to introduce our today's speaker, Engineer Dr. Gupta. one of the directors of Skeleton Consultants Private Limited, Noida. Sir has been involved in mid-rise and high-rise buildings for residential, commercial, retail, education, sports, hospital, and other sectors. Industrial buildings, PV structures, wind engineering of structures, retrofitting, and rehabilitation are also one of the parts. Dr. Gupta served as a teaching faculty at SGSITS Indore, India's tallest bungee jumping tower at Shivpuri, Rishikesh, India. It is his latest special project with 107-meter elevation of jump platform from road level from a 25-meter cantilever boom overlooking magnificent Ganges. One of his landmark project is 351 feet high Lord Shiva statue at Nagdwara, Rajasthan, has won several prestigious awards. Dr. Gupta is associated with several professional bodies. Sir was a member of NBC 2016 and BIS subcommittee CD 43 and currently representing in CD 57, 37 and 46 also. Sir has won multiple awards for his outstanding contribution to the field of structural engineering. With this, I would like to invite Dr. Gupta to take care of the next session, next part of today's webinar. Sir, the stage is yours now.
Very good morning, everybody. Very good morning, Agamani and Harsimran. I am thankful to Hilti for arranging this much relevant session. I don't say that I am an expert on this, but as a user, as a consultant, we are inclined to design of these steel structures and such developments we need to understand and implement. I hope I am audible.
Yes, sir.
Okay. And my screen is visible where the first slide is there.
Yes.
Okay. So, friends, this is good that we are meeting and discussing this particular subject, seismic design of steel structures. Particularly, there are changes with the IS codes with respect to the design and detailing of the steel structure. IS 800 we have been using, and the IS 800 under revision the draft is there, which is going to bring many changes. We already have seen IS 1893 part 1 and 5 there. We are where there are changes with respect to the seismic estimation, seismic design principles there. And then IS 18168, which is code for the detailing of the steel structure, ductile detailing. Though 1893 mentions now that 18168 will be withdrawn, it's not that the document will be zeroed. It is only that it is going to be in a different form. So withdrawn means the number may change. It may become a different kind of a document, but ultimately the knowledge which has been there in that, the information which is there is going to remain there. So in today's session, we are going to, I'm going to take you through all these new things in the 18168 or 1893 with some brush ups. There is no intention of educating you in this 40, 45, 50-minute session, but to make you aware that where is the relevant information in what form is available, so that you can start, it is just a sensitization, friends. Thankful to everyone who has joined in large number from across India. Young ones, experienced ones, everybody is there, friends. So taking you along, this is how I propose to carry the session. This is important. We all know that seismic design means the strength, stiffness, ductility, and structural configuration. These are the four virtues of a properly designed seismic structure for a proper behavior performance. I would remind you of a famous dialogue. मैंने जो रेड में लिखा है नीचे, जो झुकते नहीं वो टूट जाते हैं. आप में से कई लोगों ने इस डायलॉग को, आई डोंट नॉट नो वेदर द यंगर जनरेशन इज अवेयर ऑफ दिस डायलॉग और नॉट, बट ये एक बड़ा फेमस डायलॉग था. एंड दिस अप्लाइज टू द स्ट्रक्चर्स आल्सो, दैट अगर हमारा स्ट्रक्चर परफॉर्मेंस में, particularly under the seismic, if that structure is not designed or not trained to be flexible, not trained to be ductile or to undergo the sway or deformations, then there will be breakage, damages would be there. But more bigger question is that कितना झुकना चाहिए और झुकने के बाद फिर से उठना भी है. Means the the elastic response after the non-elastic behavior, after the you can say flexibility, after the ductility. So you need the strength, stiffness, and ductility all together. So all the provisions of the code, national Indian codes as well as the international document, they all have focused on that. Objective of this session is just sensitization about proper detailing to achieve ductility, background, philosophy, and sources for proper information. I'll show you many documents. All the documents are available with us. Many of you might be having, but if suppose anyone needs, you can always send a mail to us and we will surely share everything with you. There is nothing like I have developed myself and nothing is confidential. I have taken the help of my friends, some of the learned academicians in the industry, some of the good organizations like BIS and INSDAG and Hilti, so that I have compiled information, and this information all is available on the public domain also. Only thing is that I have tried to compile them at one place. So friends, I'll be happy to share with them all. Why all these are, after all, past earthquake performances, and this is one of the very important and very you can say exhaustive document which I have come across while going through. It's a handbook on earthquake resistant design of structure by Chia Ming Wang and others, and there is a chapter 9 on that. This chapter 9 is a very important chapter, and any of us who is interested in learning more about the ductile behavior of the steel structure, they must go through this. This particular chapter says uh, seismic design of steel building structures has undergone significant changes since the Northridge, California earthquake in 1994. Whenever there is an earthquake, actually earthquake is a phenomena which is not 100% or properly known. So whenever there is an earthquake, whenever there is a damage occurs to the buildings and structure, we intend to improve the practice. That is a lesson learned from the failure or lesson learned from the behavior. That is a very good practice, particularly for improvement in the earthquake resistant design and detailing. So 1994 earthquake of Northridge earthquake, there were several damages. So then there were a lot of changes in the philosophy. So these are narrated here point wise, particularly the braced frames from the concentric to the eccentric braced frames. The connection design was, it was thought earlier that steel is a ductile and will not undergo a brittle failure, but connections undergone the failures, and there have been a significant changes in the connection design and detailing of steel structures post the Northridge earthquake 1994. In the American code, AISC documents have been published. So these are the new connection detail. As you see in the last statement, the new connection detail fall into the two categories: weakening the beam section away from the column face so that plastic hinging is there, and reinforcing the beam section at the column face so that the connection doesn't go away. These were the fundamental things. Several of the reinforced beam column connections were developed. These all details I'll show you. And this is what IS 18168 is also emphasizing here. Now, so this is a summary from the past earthquake performance and how things were taken up. These are from the Kobe earthquake of 95. What damages happened in what kind of structures? There were bracings of different types, rods, angles, flat bars, like that. So, in the how many structures undergone collapse, severe damage, moderate damage. So, there was a statistical data collected, and then it was observed that small, slender bracings undergone more damages there. So these are some of the images from those damages, which I have picked from other literature and from the fellow colleagues from Christchurch earthquake, Northridge earthquake, then damage to the connection. If you can see, it is a local failure, local buckling is there. Like this, pre-Northridge welded flange and bolted connection were like this, where the yielding occurred, where the failure occurred just at the junction. Some more of this type, welded flange and bolted web connections, where again damages occurred, and welded flange and bolted web connections, you can see the cracking happening there. This all happened. Though the member was safe, connections failed like this. These are some of the sketches. These are some of the actual pictures of the damages in that earthquake. More images and pictures. I'm going a bit fast because these are just the historical things, and probably since you are going to get this presentation, I will ask the Hilti team to share this presentation with all the participants also. So what was the reason for the failure? The mostly welding, connection, design, materials were also there. Low fracture toughness in the welded connection, poor quality of working, certainly nowadays it is much improved, and effect of backing. You can take these poll questions also in between, and you can just give your option and submit. So that will also help you to learn and evaluate yourself. Effect of weld access hole. There was a weld access hole typically made so that the welding can be done, and that has some adverse effects on the performance of the connections. That is also very, very important. Um, Connections as per the ASTM 1992, what are the material strength, and the improved weld access hole was then made here. These are the some of the improved connections. This is the reduction in the section, development of the improved section which was done. Reinforce the connections, stiffened connections are there. This is important, as this is the one suggested where the flange is narrowed a bit away from the column face so that the plastic hinging is there. So this document is very important. Whatever I have spoken, it is all compiled here in the pre-qualified connection. Pre-qualified means there were certain qualification parameters for the connections decided, and then some of the connections have been properly detailed design, and they are compiled into this document 35822 of AISC. You all must have this document, and they are all freely downloadable from AISC site also, and we can share. We have all them for educational purpose, not an issue. This is the compiled information from Home Insurance Building of Chicago, how that failed. Empire State Building had this kind of connection. Then welded unreinforced flange connections were also there in some of the structure. And then Northridge 94, large beam and column sections were there. High stress strain at the welded connection, which led to poor welded details. And brittle weld electrode material. This was another important parameter, the material of the electrode. So all these have been taken care of in our these two new codes, IS 800 and IS 18168. 800 chapter 12, section 12 had MRF, CBF and EBF. MRF, moment resisting frame, concentric braced frame and eccentric braced frames, which are converted or which are advanced into 18168 as a special moment resisting frame, special concentric braced frame, and EBF, eccentric braced frame. In terms of hierarchy, if I say performance wise, EBFs are the best, SCBF after that, and SMRF the lowest on that. Performance of the structure as far as ductility is concerned, the performance wise. In these codes, particularly 18168, these are applicable to all the buildings located in seismic zone 3, 4, 5. Now this has to be updated in light of 1893 part 1, the new one, 2025, and the part 5. The zone numbers will change. This 18168 is the just a little old, so 2023. So this will be updated and will be brought or published as most probably IS 13920 part 5 B. IS 13920 part 5 A would be ductile detailing of RCC structure, whereas this is going to be there as part B for steel building. So then these code zone numbers would change. Means in the higher seismic zones, in all buildings, this is compulsory. Residential, educational and others. Use of this code is optional for the design of zone 2, means the moderate zone. In zone 5 only EBF system. As I said, um, that performance wise EBFs are better. EBFs are best in the energy dissipation. They provide a proper flexible link in the structure. So a sway is there. While the concentric braced frames or special concentric braced frames, they impart strength and stiffness. So they allow a lesser of the lateral sway. So there is a compromise between the two. However, in high earthquake zone, EBFs perform better in case of energy dissipation. Correct. So more qualifying statements are there. The capacity design has been emphasized. There is another poll question. Please attempt that. There is another. This capacity design concept is there, which says you should identify ductile and brittle members in a structural system. You need not design the entire system, entire structure, every element for the ductility. You can identify like which link to be failed, so that the user or the agency is taking care, they are aware that where all the vulnerability is there. So in SMRF systems, ductile elements, which are ductile elements in SCBF and in EBF system, which are those elements which should be protected and which can be allowed to undergo the ductility that is defined based on the capacity concept. This should be understood well and followed. Many regions of India are prone to strong earthquake shaking. Now it's almost 65-70% is on the stronger, 70 plus as per the new map. So we need to take care of proper detailing. The only thing is the last statement, which is important. Provisions of this standard shall govern when in conflict with those in Section 12 of IS 800 2007. Because Section 12 of 800 2007 will still remain there. So the provisions of 18168 or the updated 13920 Part 5B would govern in case of any conflict between the two. When you go through the course, you must understand these qualifying statements, very important. The provisions of this standard apply for design and detailing of steel buildings having the following structural system. All these we have discussed that they are applicable to these and what kind of buildings they are. Load combinations. Load combination, there is an additional overstrength factor which has been in addition to the partial safety factor for live load. It is there, and then on the earthquake there is an overstrength factor. Now overstrength is something which is beyond your calculated values. There is an overstrength available in the structure. Having overstrength is not very good from the perspective of the seismic performance, because then the anticipated behavior, ductile behavior doesn't reach at that particular point. And then when you go to the capacity concept, the other elements have to be designed for a larger capacity than that. So code has incorporated this overstrength factor for different structural systems in the design to be considered. Load combinations, 18168 says use table 4 of IS 800. So that has been reproduced here. Simple. In different load combinations, what load combinations are to be, load factors are to be taken. Same thing, this is also referred from table 4 of 800. Material strength uncertainty factor. Yeah, this is given there in the code. Those of you who are aware and have gone through, they will be able to answer it very quickly. Please attempt this question. There are three things in the code which have been emphasized. One is the material and the section. Second is the structural system, which is important. And third is about the connection detail. These are the three important things from the performance. For material, IS 2062 is the code which is referred, where structural steel sections and plates of grade E250 to E350 are recommended for use. Any other equivalent grade of steel satisfying the following can be used. There may be a question in mind, what about 450 grade? Actually, 450 grade is a high strength grade. It can be used only for those elements which are not supposed to be ductile during the earthquake performance. As I have said, you can decide that some of the elements you can choose to be ductile. For those elements which will perform or which will govern the seismic behavior, it is better to use a 350 grade because it is a proper balance between the strength, stiffness, and ductility. 450 in those where strength is important but not the ductility. So non-seismic or non-fusing elements you can say to be used 450. This is the material uncertainty factor, material strength uncertainty factor, which is always more than 1. This question you just passed. Uh, Bracing members shall be made of E250B steel from table 2 uh, because they will undergo larger deformations. So it is recommended like that. Below is given the stress strain curve of 350 and 450, more or less behaving same, except 450 is a little higher on the stresses side for the same strain. This is the entire table of 2062, which is very important for all of us engineers, that which grade of steel to be used. We all should refer to this along with the HRP impact value. Some more parameters are there in the continuation of this table. As per current manufacturing standard, 250, 350 both are acceptable, and otherwise there are some more higher grade steel such as 450 can be used provided proper anchorage and confinement are ensured. Okay. In two different cases, with using the higher grade and the lower grade, how the structure will behave, how the plastic hinging will be there, that is shown here. 4 classes of the sections are there. Compactness criteria starting from plastic, compact, semi-compact, and slender. Mostly we go with the plastic and compact for the better seismic behavior. It is recommended. Uh, Width to thickness ratio for different elements, beam, columns, braces, and links, which what should be followed so that you do not get these kind of the things here. They are given here in this table. I'm not going into those details. The desirable and undesirable performance, where the plastic hinging should happen and where it should be avoided, is shown here. There are two documents which are there. One is SP6 part 1 and one is IS 12778, where there are steel sections given. There are 65 sections in the please take another question. There are 65 sections in SP6, whereas 192 and 12778, out of which 28 plastic sections are there in SP6 part 1 and 132 in the this one. So this is just a statistical analysis of the data. The eccentricities less than the beam depth are permitted if the resulting member and connection forces are addressed in the design as per the clause 12.2.1. If you look at this clause, then there are some protected members shown, that the required strength of the capacity protected elements like columns, beams, struts, collectors, and connection shall be taken as the larger force determined from the following analysis. And these protected zones, I'll show you in a diagram just a bit later on. A rigid diaphragm shall be considered to be rigid if the maximum lateral displacement measured from the chord of the defined shape, it is just the lateral movement. So how that will be considered as rigid, that you have to take care. And then you follow this. K-braced frames shall not be used in SCBF, special concentric. You can only use the diagonal and the cross and the V. The protected zone shall satisfy 5.4 like this. For the braces, the center 1/4 of the bracelet, there are provisions of that, where it should be and where it should not be, which zone should be protected. So like links shall not be connected to the columns. Focuses on ensuring what during severe earthquake shaking. This is a good question. So there are certain requirements laid down in 18168 for different kind of sections for the performance All these protected zones of EVFs are the links. They should be protected. Use of shear studs on the link is prohibited. Brace members beam outside the links and columns shall satisfy width to thickness criteria. So these should be followed. These are the protected zones which should follow those criteria. They should not yield or fail. That is the protected zone specified. Correct? Some more provisions going ahead. This is very nicely narrated in 18168, and going through that, if you make your checklist, the life will become very easy as far as steel design and detailing is concerned. Few more. OCBF, ordinary concentric brace frame systems, there are provisions for that. Is provision only for diagonal and cross bracing. V and inverted V to be designed as per the specialist literatures, and K braced frames are not permitted when you go with the OCBF. Some of the bracing systems using OCBF are there. Some of the actual images, how they look, how are they done, and design of bracing members as per IS 800 class 1272 are given. The slenderness ratio and the rotation, the along any line of bracing, braces shall be provided such that for lateral loading in either direction, the tension braces will have to resist between 30 to 70% of the total lateral load, not beyond that, like this. So these are the points which should be taken care of, and 18168 has done picked up from the past experiences and very nicely done. Here, if you see, in buildings like Hancock Center, Chicago, or some warehouses, concentric brace frame can be approximately modeled as vertical trusses. Yes, you can always do that and analyze them. Like this tower also. Initially, the braced frames were used for their high strength and stiffness. These are OCBFs are high strength stiffness elements. And then seismic provisions were introduced late in USA. In India, now we are picking up and emphasizing on them. Although moment resisting frames were popular, the use of braced frame got importance after 94. Till then, they were thinking that moment resisting frames are good, and most of the buildings were like that, but they suffered severe damages. So then they switched over to the braced things. Brace deformation, brace tension yielding, buckling would be like this, and then cyclic response would come this way. Not a very good from the earthquake point of view. The brace section should be selected based on the slenderness criteria and compactness criteria. So more such things are there. Actually, it's a very exhaustive document, and there are many things. If you see, there are 186 slides. I hope time is not that much, but certainly we can have sessions specifically dedicated to smaller segments out of this, like a session on the structural system only and like that. So these are some of the critical parameters on the uh, OCBFs listed here, which IIT Professor P.C. Ashwin Kumar has very nicely dealt. There is a very good video of Professor P.C. Ashwin Kumar on YouTube, which you all can refer, where things have been explained in detail. So that also would form a good reference, friends. So I'll just skip a few things about the balance design procedure. Then special concentric brace frames are there, which are to be detailed such that we get desired behavior, the ductility, shifting from strength and stiffness to the lateral side, to the ductility. That is the SCBF arrangement is there. Uh, what are the configurations permitted with SCBF and what are not, that are shown here. Design guidelines are there of SCBFs. Then this is very important, eccentrically braced frames, wherein we do not connect the bracing member to the corners, but to a member with some eccentricity, and there is a shear link which is connected. This shear link helps a lot in the seismic energy dissipation. As of now, this is one of the most advanced area, but There is one more beyond that, which I'll show you, which is yet to be in the code. But Professor D.R. Sahu from IIT Delhi has done very good research on that, published. Fortunately, I have been interacting with him, and I'll show you that some of the things beyond the EBFs are also there. But as of now, 18168 emphasize on use of EBFs in the higher seismic zones. Uh, EBFs, though they involve a little more complex analysis and all that as compared to SCBF, but they perform better. The one requirement is that they should be laterally stiffened. Any member with the EBF should be laterally stiffened so that there is no sideways or lateral movement of the element. And the link rotation angle should be how much, that is important. I'll show you what is that. This is the link rotation angle. It should, there is a limit given to this link rotation angle. It should not be that much. All these things we need to take care in the analysis, and then it performs very nicely under the seismic effects. The requirements like this, you can see the mechanism, link to beam column connection and link to column connection, which is not a recommended one. The link to beam connection is the more recommended one, which should be followed like this. Ordinary moment frame and special moment frames, in some cases we have to use them without bracing, so moment connections are there, and there are provisions with the doubler plate and the continuity plates are there. And then this is the new latest development, BRBS, buckling restrained bracings. Buckling restrained braces are very good as far as strength stiffness is concerned, as far as the energy dissipation is concerned. So this is a new area where more work is being done, and I think soon they'll be implemented. So they are like this. Uh, all these braces, the main problem with the bracings, in earlier sheet also I have shown that the failure of braces occurred because of the buckling. Here the buckling is restrained by fuming. In this it is shown as concrete is filled, but otherwise there are other ways also of restraining. Friends, connections, most important, because the member, it is said that the connection should not fail. Our members are designed for the capacity, and the connection should be designed for the entire capacity of the members which are connected there. Correct? So these connections are very important. And therefore, these documents like extended end plate moment connection and pre-qualified connection for seismic performance, these are very important. Our code doesn't say much on these things. However, uh, provisions and the details from these documents help a lot that we should prefer. Some of the points I have taken from AISC. The global response behavior expected should be like this, that a frame, the buckling of braces, maximum tensile strength is achieved on the other side, and column attains maximum rotational capacity so that columns do not fail or yield. This is a desired global behavior. On the beam to column connection, up to 5-story buildings, simple connections are allowed. However, then semi-rigid connections and then rigid transfer connection as you go up are there. Typical beam column joint where there is a doubler plate or continuity plate depends on the design, forces, height of the building and earthquake zone, whether it is required or not. Uh, End plate connection with and without stiffeners are also in use. Beam to column connections like this varieties, only the bolted connection or bolted connection with a stiffener. Both the types are there. Some of the failures, some of the performance images when the earthquake comes on these kind of connections are there. Behavior of ductile steel structure under earthquake load. Actually, uh, you can see this image on the right side, that the water tank is still there. It has not undergone, it has not collapsed, just because the structure could undergo a sway. So it still survives earthquake through ductility and not just the strength. That is very important. Designed to yield from plastic mechanism and dissipate seismic energy. Controlled damage, no collapse. Large deformations are acceptable. Damage is a gradual and visible, giving warning and evacuation time. That is the advantage of the steel. Seismic energy is dissipated through stable yielding and plastic hinges. Forces are capped after yielding, preventing force escalation. It only flows then. Plastic mechanisms act like fuses, protecting brittle components. This is very important. And we use this in RCC also to some extent. Load redistributes after yielding, improving overall robustness. So there is the indeterminacy plays a role. Structural redundancy increases, enhancing global stability. This is very important. Damage occurs where intended. It is we should govern the performance. That is the performance based design. Behavior is planned and controlled, not sudden or brittle. So these are the important things as far as performance is concerned. Now, our codes 800 as well as 1893, they mention some of the new things. This is 16700. They speak about the structural system, the frame system in tall buildings. Then additional criteria is given in 1893 part 125 are that more or less some of the things from there, but then which structural system to be used in which zone, this is given in 1893, the latest one, part 5. And then additional criteria with regard to the response reduction factor for different. So this we have to adopt from here about the steel buildings. And for residential building, you can use this, and for higher zone buildings, you have to use this kind of analysis. That is important. Steel buildings with open stories, you have to have the bracings behaving like shear walls, continuing from bottom to top. You cannot discontinue them at the lower level. Those kind of, and then stiffness of the lower stories are important. So these are the provisions in the 1893 part 1 and 2 here. So I have just taken you through the important aspects from each of the codes. However, there is a long list of the references, which is 800 2025. Yeah, this is a good question. And I think with the discussions, with the whatever I have informed you, you will be able to answer that survey. So first are the Indian codes up to IS 2062, and then there are AISC documents plus the handbook on the seismic design, which will provide you a good insight into the phenomena, the performance, and then some of the design guides are there. I think uh, these are the cover pages of all those things, just for the reference that these are the documents. I would conclude the thing here with the acknowledgement to Hilti, to the live stream who are giving us this facility to live stream, and sources including INSDAC, Professor P.C. Ashwin from IIT Roorkee, Professor D.R. Sahu. I have been talking to these learned professors on the subject BIS for continuous upgradation. All of you who are here, and we'll certainly enter into some question answer and discussions. My office team who have helped me in this presentation, and parents, family member, and clients who give us work, so that we learn. See, only theoretically studying we may not be able to do better. Certainly we implement them on the projects, and then how we develop ourselves. Thank you very much everybody, and these are my coordinates. You can write to me on mail, and we'll send you the documents, we'll send you the response on the WhatsApp also. Generally, you will get a response in 2 hours time maximum on your queries you send to me. Thank you, Agamani. There are more things. I'm not going into that. Maybe I'll share separately. But we can stop here for today for further discussions.
Thank you, Dr. Gupta sir. I can see some questions in the chat, which maybe because we have some time, we can maybe take that. So I can just read it out for you, sir. The question came from Mr. Dixit Patil. If EBF systems are better than SCBF, Then why overstrain factor for EBF system is higher than SCBF as per IS 18168?
Actually, your question has the answer. System is better, it is able to resist more forces. Overstrength factor is not a safety margin. Actually, overstrength factor is an accounting for higher capacity of the system. That is the importance. Even if I ask you a simple question that please calculate the load carrying capacity is how much a single point load an RCC beam of 300 by 300 millimeter size reinforced with such and such reinforcement can carry, uh, with all the factors which you have, you will calculate the value of that load P, WL by 4, and you equate it to that, and you will get the PL by 4 and get the value of P. No, but in that you are not accounting for when I am designing an M25 concrete, I am getting and using only a part of that, I am getting much more strength. When I am using an Fe415 strength steel, actual UTS is much higher. So those over strength actually give me a number which is higher capacity of this section. When the capacity is higher, the capacity design concept says I need to design my other component, the connections, etc. For that. So otherwise, my structure will not go to the plastic range if I have not taken care of that. It will not go there. So over strength for a better system will be a higher over strength factor. I hope I am able to answer.
Yeah, thank you, sir. And moving to the next question, which is from Vaibhav Naik, Mr. Vaibhav Naik. What are the considerations for truss member placement at the preliminary stage of frame design?
Pardon, come again.
What are the considerations for truss member placement at the preliminary stage of frame design, bracing system?
Bracing system. Now, depends on in which zone you are. If suppose you are going for a concentric braced frame, then placing bracing any at any location where architecturally permitted and it is able to dissipate, means translate the forces to the foundation. That is one thing. And secondly, that it should be symmetrically placed. You should not stiffen one side of the structure. It should be symmetrically placed. In some of the recommendations, K bracings are allowed, in some are not allowed. So that care you should take from there. If it is a higher seismic zone, rather than CBF, go with the EBFs. That is
Yeah. Third question from Mr. Pushkar Kokane. Sir, explain about the connection. It is not economy using new code. Steel consultants ask us for 4 multiplied by 1.2. That's the question. Explain about the connection. It is not economy using new code. Steel consultants are asking to multiply by 1.2.
it is given as per chapter 12, section 12 of 800. You have to enhance the capacity of the connection. That is again for the overstrength only. So there is nothing like it is not economy or it's a heavy design. It is the stipulation from the code, from the performance point of view. If you can somehow change the configuration at the connection, means if you can reduce the section near the connection, then it will help. Means your capacity of the member at that point if reduces, then 1.2 will also be reduced. That is the way. Otherwise, whatever member is meeting at the connection, you have to design for its 1.2 times as given in the code. It's not economy's question, it's the question of the performance.
Maybe the last question we can take Harisha SM. He has asked that what is the impact on friction grip bolts design with sleep critical condition?
What is the impact of?
Friction grip bolts design with sleep critical condition.
What is the impact of friction grip bolt design
Yeah,
with slip?
critical condition.
No, it has nothing to do with the seismic structural system design. It is
Yes.
only recommended in case of some structures where there are vibratory loads to prevent from getting them loosened.
Yeah, because it's basically working on the principle of friction grip and like that. I mean,
Yes,
HSMG or something
so
like
this
that.
has nothing to do with the seismic design of the structure.
Yes. Um, Maybe last one just now we received. Sir, can you, it is from Amir Afzal. Sir, can you please elaborate how to check 30 to 70% tensile forces transfer?
Pardon?
Uh, how to check or ensure 30 to 70% tensile forces transfer?
That's simple. That's simple. You have to perform one analysis, check how much force is being carried in the braces, and if it is higher, then you have to uh, change the section. That's all. If suppose it is carrying more, you have to perform one round of the analysis for that.
Yes. Um, then there was a more elaborative question. Maybe we can take quickly. In PEB design, sections are often semi-contact or slender for economy. However, in seismic design, compact or plastic sections are recommended to ensure ductility. Why is there this difference in recommendation, and how should we decide which type of section to use?
Compact and semi plastic sections perform better under the seismic higher seismic zones, so we should go with that. However, the PB structure, single story warehouse structures, they are generally not governed by the seismic forces, they are governed by the wind. So there you can certainly go with the slender or semi compact things.
Okay. Um, Thank you for putting all the questions in your chat box. If you have more questions, please reach out to Sir directly or you can reach out to us also. We'll be anyway sharing this presentation later on. And I think we are at least actually at the end of the session today. And I'd like to thank you for attending today's webinar, which is on seismic design of steel structures, the
Uh,
introduction part from
I
theory to
would request
practice.
all of you
Yes.
to continue to write to us. That will
Yes.
initiate a very good communication channel. We are also in the learning stage, to be honest. Okay. And we are also waiting for the new IS 800 to be published and then revised form of the 1816 set. So, this is required that we keep on communicating. So, please
Yes.
keep on sending.
Yes,
This
sir.
presentation can be shared. Agmani, you can share
Yes.
this presentation
Yes,
with
yes.
all.
I will share with all the participants after the session. And a special thanks to you, sir, for your time, effort,
And
and
not
generously
this
sharing.
presentation, the one which I have sent to
Yes.
you
Yes, I'll
earlier,
share.
two slides
Yeah.
on one, that one.
Yes, sure, sure, sure. So we'd really appreciate you taking the time to join us and hope you found the session insightful and you got some practical takeaways also to support your day-to-day activities. And yes, as we already discussed, you if you have any further questions and would like to get more additional details, please feel free to reach out to us. And I'd like to thank you once again. Thank you, Dr. Gupta, and also thank you all the participants for your active participation and engagement.
Thank you. Thank you, everybody. Thank you, Hilti and Harsimran.
And I would also request you if you can share one key takeaway from today's session in the chat box before you leave, then it will further motivate us to conduct such things in future.
Okay,
Okay,
bye bye.
thank you.